Actually, this is my first time at this motorcycle forum. So when Mike approached me a few months back and asked me if I was interested in coming and presenting and be part of this community, I just got literally super excited because I really like this environment where we can share, information that we have, but also from my perspective, especially research needs and what the public has to say about that. So Mike mentioned a little bit the type of work that I do at TTI. I work in College Station on the roadside safety devices. That's a fancy word for anything that you see on the road, like guardrails and treatments, concrete barriers, signs. And I work on designing them and full-scale crash test them. So because when we develop these devices, we want to make sure that they behave as they are supposed to behave, but at the same time, we want to make sure that they are crash-worthy. So that means that they don't constitute any more danger to vehicles that are errant, and so they don't constitute any problem for the occupants of these vehicles. And I should probably say for riders on motorcycle too. I would like to go through the motivation that brought me here today, and especially the motivation of doing the work that I like to present to today, and talk a little bit about the standards and the technical specifications that are worldwide. It's going to be interesting. I hope it's going to be interesting for you to hear what I'm saying. From this perspective, I'll show you a very few crash testing programs worldwide that exist. And I also would like to dedicate a little bit of time to explain you what we do at TTI from this roadside safety perspective with motorcycle safety, and particularly talking about a computer model of a motorcycle that we have developed, and why we did that, first of all, and how we are intending to use it, and what we think are the needs for future work and future research that would affect all of us, and especially the motorcycles community. So I talk a little bit about roadside safety hardware. I mentioned it's really anything that you find on the road. It's actually not really true saying anything that you find on the road. I will have to be a little more specific. If you think about the need that we have to convey information when we are on road, for example, we need to have signs to say, where we're going, how fast we need to go, and give general information. So we put these signs on posts. Or, if you think about, we have bridges, we need to put rails on bridges because we need to make sure that if anything happens to some vehicles, and these vehicles are errant and then they just go off the road for whatever reason that is, we need to make sure that they just don't go down the bridge, or they don't go down the slope, or they don't hit whatever hazard is behind those guardrails. So basically, what we need to do, we develop devices that need to shield hazards, that need to contain the errant vehicles in general. They need to redirect the vehicles. At the same time, though, they need to be safe for whoever is in the vehicle, or whoever, again, I should say, it could be even a rider. We're lucky that since 1960s, we have had standards that we follow in order to test these devices. You can see here the history of the testing standards that we have. Actually, the very latest one is literally coming out in days. It's more an update of what we had in 2009. Now, the big thing about that is that the good thing is that we have a very good testing program. So we know for passenger cars, pickup truck, heavy vehicles of different types, what type of condition we need to test these devices. So if we have to hit a guardrail with a car, we know it's going to be for 25 degrees. It could be 44 mile per hour or 62 mile per hour if it's a slow or a high speed, low or high speed road. The problem is that there is nothing, unfortunately, for the motorcycle community. There is nothing in these standards that talk about how we should evaluate motorcycle impacts against the roadside safety devices. So what about motorcycles? So here is the thing. Unfortunately, there are very few things that I would like. Well, there could be more, but I like to touch on a very few things right now. Unfortunately, there is very limited research to address rider safety when impacting roadside safety hardware. All this morning and later on, we have been talking, or we will talk about, problem with speeds or alcohol or education for riders. But when you have and this is kind of it kind of gets personal because that's my area, when you develop a guardrail or any type of device that you place on the road, you really want to make sure that it's safe in case it's impacting by motorcycle, and especially by the motorcycle rider. But we don't really know what I was mentioning before. For a vehicle, we impact at 25 degrees and 62 miles per hour. That actually represents the 97% of the overall encroachment data for that specific device. So we don't really have any data, or at least in the US, that tells us this is how you should test this device, this guardrail or this post or whatever that is, with a motorcycle. And it doesn't tell us, even more, it doesn't tell us if it has to be impacted sliding or upright or inclined. It doesn't say anything. We don't have that data. I would like to touch on a couple of other things. In the US, there is no existing standards for motorcycle rider safety when they impact roadside safety devices. And worldwide, there is no standards to evaluate these motorcycle impacts against roadside safety barriers when impacting in an upright position. There are, and I'm going to go very quickly through today, there are some attempts and some specifications that have been developed, especially in Europe and also in Australia, to evaluate how to possibly test motorcycles, which is really not motorcycle, but would be riders, motorcycle riders when sliding, but nothing in terms of upright position. And it's kind of upsetting because there are studies that have been shown, especially in Europe. Again, I have to bring up not in the US, or at least that I'm aware of, but in Europe, there have been studies that have shown that 50%, roughly 50% of the impacts of motorcyclists against roadside safety barriers occur in upright position. So the question would be, do we need standards for motorcyclists or to test the motorcycle impacts? And I'm not going to talk too much about these numbers because you have seen a lot of numbers this morning that might have been even more accurate than what I'm showing you. We all know, and I think that's the purpose of this graph, that we still need to do a lot about the motorcyclist safety. This is the trend for motorcycle fatalities, and that it's basically kind of constant throughout the years, or at least in the past decades. And you see here the tendency of a passenger vehicle occupant deaths that is slightly going down. So there is a lot of proactiveness to work on safety for, again, other type of vehicle fleet. But from my research area perspective, not much has been done. Although there were some attempts. There were some attempts like these standards and specifications that I'm showing you right now. This has all been developed in Europe, so I don't want to talk too much in detail about these. It's very technical, but I like to at least briefly touch on some of them. So these, and I'm not going to call it standard. This was actually more a procedure that was developed back in 1998 in France. It started in France. And what they did, they wanted to develop, again, not a standard, a procedure. So that means that the country is not mandatory, doesn't have to test these devices, according to this procedure. It's up to whoever developed, whatever wants to be tested. This procedure is specifically looking at the situation where you have the motorcycle that slid, and so the rider just leaves the motorcycle and keeps sliding, and then it's impacting whatever type of roadside safety hardware is impacting. Could be a guardrail, could be a concrete barrier, could be anything else that you want to evaluate. So you can see it's no upright situation, it's just sliding. This will be a dummy that can be used, or at least at that time in 1998 when they developed, it was a whatever degree they chose at the time, 30-degree angle, and it was a 37 and something mile per hour impact. Now, very briefly, let me keep going on the history. part, this procedure was actually then taken from France in Spain, and they kind of retouched it a little bit. They further developed, they made it as their national standard in Spain, but just in Spain. And then in 2008, they revised it once a little bit more, and they added 143 miles per hour testing. Again, more or less the idea was the same. It was a sliding configuration, no upright configuration, but they just added these 43 miles per hour test. One more thing. In 2011, the EU, the European community, started getting very interested in this argument, or in this topic, I'm sorry. And so what they did, they added a part to their, again, standard, but they made it not as a standard, as a technical specification, and they wanted to start in testing devices, roadside safety devices, by considering impact with motorcycle riders. Once again, not in upright position, but in sliding position. Unfortunately, I call it here technical specification because it never became a standard. And again, just some pictures, and it's still the same. It's not really much different. The nice thing about it that I wanted to mention about this technical specification, even if it's not a standard, I mean, it's great that some communities are very proactive on that. So when they had to develop this procedure, it's not as easy as somebody might think. You have to think about what are the conditions that you want to test, but also you have to think about how do you assess the behavior or the the validity of the test, and how do you assess if the test can be considered a pass, no pass. So there are different things that you have to think about. And so here on the right, what I was showing is basically they gave, these are just some examples, it's not all they have done. They have done more, but they basically starting to say, okay, well, if I have this rider that is sliding on the road and is impacting this device, in this case, it was a guardrail, but again, it could be anything. One of the things that they looked at, because that was one of the most important things to look, is what is interaction between the rider and the device, and specifically, do we have like any protrusion of arms or other parts of the body, really any part of the body that could constitute, a bad injury once impacting this device. And also they added a quantitative evaluation of this study, because we call it, the easiest way would be a dummy. Technically it's called a ATD, anthropomorphic testing device. So the ATD, which is the dummy over here that was sliding, is actually instrumented, has different instrumentation in different parts of the bodies. And so by collecting the instrumentation data, like accelerations, we can calculate forces and moments. And so then we go into the biomechanic component, and we can say, well, if the YARS values tell me that I cannot go more than 1,000 for example, the head, well, of course, if I'm over 1,000, I can consider the test a no pass, because I would have an injury that would be incapacitating or extremely severe or even a death. So I think that was the nice part that I wanted to bring up and give credit, because it's a lot of thoughts about that. However, here are some constraints and some problems that came out. I was mentioning before, it's not a standard, it's a technical specification. So this was a comment that came out from UK, was actually TRL at the time. I'm not sure that TRL is still around, to tell you the truth, but at that time, they clearly brought it up that UK was not going to test according to this technical procedure, because it's not a standard. So number one, they are not obliged to do that. And number two, the cost involved with these tests, especially if you consider having an instrumented dummy, the cost can be pretty high. And it's totally understandable. It's just that at this point, the question would be, well, can we do something else so that we don't stop the research and we don't stop the improvements just because of, costs? Can we find another way? And I'll get there in a moment. Now, switching a little bit the topic, but staying in the standards, probably you know, have you heard of the ISO 13232, which is a standard. Actually, it's a international standards, but these standards deal with how to test and how to evaluate the impacts of motorcycle against cars, or against vehicles in general. So it's not exactly the same thing, having an impact against a car or having an impact against any roadside safety device. For example, just think about when you have a roadside safety device, a post, for example, or if you have a combination rail, or even if you have just a guardrail, you have a lot of interaction. If you have a rider impacting against it, you have a lot of interaction. With a car, the behavior is a little different. I'm not saying that it's less severe or anything. I'm just saying it's different situation. So although there is an international standard, and I think we can take a lot from it to develop possibly another standards for roadside safety devices, it's still not the same. And we cannot just take it and apply. It's not the same thing. The nice news is that although we don't have standards and we just have this basically technical specification in the EU, there have been some countries, and I have to say that Germany is probably one of them, and together with Australia, that have been very proactive from this perspective and have developed different crashes, or I shouldn't say crash procedure, but they had situations where they crashed its motorcycle even in upright position. So they've been very ahead in the community itself. Let me show you, I don't want to spend too much time on this. This is literature. I want to show you, I decided to show you 3 examples just to give you different flavors of the research activity that's been going on since 1980s up to a few years back. This was 1988 in France. I thought it was interesting to show you this. This was a study that wanted to look at designs to reduce aggressiveness of guardrails. So you're all familiar, by the way, this is not a US guardrail. The US guardrail is a little different. And it's interesting, actually, to see the differences between the US and the EU guardrails. But anyhow, still we have a post and we have a block out, and then we have the rail. That's normally how a guardrail is. There are different types, but that's what it is. So what they did here, they said, well, let me place a beam on the top and a beam on the bottom, try to kind of, close up the gap that otherwise you would have if you have just a post after post after post and it's completely empty underneath. That was one thing. And on the top, the beam that they wanted to include, it was to make sure that there were no protrusion from the test article that could have better interaction with the rider if impacting. They also decided, well, what about if we take away, they were trying to see a different design. So what about if I take away the beam on the top and I modify it a little bit on the bottom so it's less stiff? I mean, you get into technical things and different type of design and what exactly you want to accomplish. Keep in mind, all the evaluation, all the changes or all the considerations that they have made to the designs ultimately still needs to be tested according to what are for them, because in Europe they have it too, what are the testing programs for vehicles. So you can modify whatever you want right now, but then you have to go back and test it with the vehicle and make sure that it's behaving as it should. So it's not so easy. You have to consider different things. These were just a few other data that I wanted to include. I don't know that we want to go into much in details, but I guess I wanted to show you with this paper or with this study that guardrails themselves can be a little tricky. I mean, there can be a lot of improvements or a lot of things that can be done, or at least not saying that can be done, but can be investigated to see if we can do something to improve the behavior. 2005, that was actually done between Australia and Germany. There were some, I'll show you in the next slide, there were actually some full-scale crash tests that were developed. And they developed full-scale crash tests with upright motorcycles and also with incline motorcycles, or actually sliding motorcycles. And they use different type of barriers. They look at the post and beam, so the guardrail, and they look at the concrete barrier, because the behavior is going to be different. I'm not saying that impacting the guardrail will be necessarily worse. I'm just saying that the impact is going to be different, and there are different things that we would have to consider. Although with a guardrail having the post, one might think already, we have some issues over there. I thought it was interesting to bring up this study, well, first of all, to show at least the proactiveness, but at the same time to show you that they actually have used dummies, and in this case, it was upright motorcycles, so they have used dummies to evaluate, what the injuries and possible rider. Normally, when we, in roadside safety, when we use dummies, well, it's a little more complicated than that, because in roadside safety, we actually don't use instrumented dummies, number one thing, because we have other ways to evaluate occupant risk, not because we're not looking at that, we just have another way to do that. But in this case, if you're talking about a rider, you have to consider, there is no other way, you have to consider a dummy, because you have to have the real interaction between the rider and the barrier. You cannot do through some acceleration of the motorcycle. That has nothing to do with what happened to the rider. So what they did, they used what we call the hybrid 3, and I'll briefly show you in a couple of images later on. Now, that's great. That's what we have that is available. It's relatively cheap. Fully instrumented cost around $200,000, I'm sorry. But the problem here was that they realized, oh, wait a second, these dummies were validated in frontal impacts. They were not validated for 15 or 30 or 20 degree impact. They were validated for frontal or very few impacts. So that was the other question mark. What are we going to do? Are we still going to use these dummies? Are we going to look into development of others? And it can be a little tricky even there. This was one study that I wanted to show you, because we actually developed way before my time, early 2000, at Riverside in our campus, and where we did some head-on impacts against the barriers and vehicles. I talk a little bit about the dummy, so I'm not going to spend too much time here, but I'd like to show you this just because, well, this is just a general picture. I didn't mean to show anything specific with that, but I wanted to kind of show you, when the dummy is on the motorcycle, there are different types of interaction, obviously. The other thing that I wanted to bring up is that in the roadside safety community, when you especially when they do impacts on motorcycles against cars, they have to modify the dummy that we have, because the dummy that we have wouldn't sit properly, wouldn't behave like a real rider. So there are some modifications that had to be studied and enhancement from the biofidelic perspective. Why computer simulations? So here is what I wanted to talk to you about what we have internally funded at TTI in the last maybe year and a half. It's very expensive testing with motorcycles. We have done it. I'll show you very briefly later a slide on that. We have done it, but it's very expensive, especially when you start considering a dummy on top that is instrumented. So another efficient way, which we are very familiar and we do all the time when we do our testing with roadside safety devices with vehicles, is using computer models. So what we did, we developed a computer model. And let me show you, I think this is a little interesting, so I'll show you while I talk. So what we did, we took a motorcycle. It's a long story why we chose that one specifically. It was tied to a project that's confidential, so I cannot talk too much about that. But we dismantled the motorcycle piece by piece. We scanned it, and then we developed for each little part, and in connection, we developed a model. We developed a surface, a mesh, and ultimately we had our full model, which there it is right there. We also are including these latest efforts that we're trying to complete in the next few months. We are adding the ATD, the dummy that we were talking about. It's not going to be geared, but at least it has the helmet. That's a good thing. We have used that. We use the motorcycle model. Right now it doesn't have the dummy on top. That's just preliminary simulations. I don't know why it's not going. But if you see, there is a profile here. It's one of one of the barriers that we have normally in the US. And what we're trying to do is evaluating the interaction between a motorcycle and different type of barriers. That's what we're trying to do right now, and especially what we call combination barriers. And this is actually, let me see. Okay, so this is actually a picture that we took. I could not show you a video being confidential, but this was a picture that we took. This is the dummy, full geared with helmet. And if you notice on the bottom, we have developed, so when there was a DOT, that was not Texas, but there was a DOT that came to us and basically asked us to develop a testing program with motorcycles. To evaluate a specific interaction with a barrier. And so we got to the point where we had to develop a testing program, not standard, but a testing program, and we basically started from zero. And so we had to find out what speed, why that angle specifically, what type of motorcycle even to choose. That's another thing. What motorcycle are you using? There are different types of motorcycles, and the behavior of the rider can be different. And so the nice thing about this is that what we do, we use a tow cable system. So the motorcycle is completely free. Well, it's first attached to a cable, and the cable pull the motorcycle at the maximum speed that it should go, whatever speed was there. I think it was 45 miles per hour. And right before impacting the barrier, we release, see on the bottom, there is this part here, and even the wheels, they completely released. So the motorcycle is free to in upright position to impact the barrier, like if it was in real life. So there is no interaction or nothing with any system that we have with the dummy on top. And we saw some interesting stuff. That's why later in the past year and a half, we decided to develop the computer model of the motorcycle. So I just would like to conclude my presentation by showing you a couple of examples. I don't want to put across anything, but if you look around when you drive, maybe when you drive no, but when you are like a passenger, if you look around and you see all the roadside safety devices around, try to imagine what it would happen if a motorcycle rider impacts them. You can have a situation like these are really not combination rail, but let's call them like this. These are, let's call it combination rail. When on the bottom you have a certain type of rail, on the top you have another one. In this case, actually, it's not very hard to do something to improve the behavior of the system so that it doesn't hurt the rider. Because this is very simple. They are just have some post, and there is the the fence, the net. So you can kind of go and develop some breakaway devices on the bottom or shield. The problem comes when you have real combination barrier, and the top, like in this case, again, this is just an example, and the top needs to be compliant with IRB or AD8 code, and you have a specific design loads that you need to meet. And these things are extremely hard to break, even with vehicle. Imagine if you want to break them with an arm or with a person. So that's more or less where we're standing right now. We are in the process of developing some testing possibly, or to validate anyhow the model that we're doing, the motorcycle model, and including finally our ATD to evaluate the injuries and the severity of crashes.